we can generate candidates, we can optimize, let's say, the design of a sequence and so on. And now, thanks to our approach on machine learning for quantum chemistry, we also have good property predictors. So can we push more and more of the work of designing a new antibody to be completely in silico, as opposed to having to do a lot of wet lab experiments, a lot of rounds? Can we push more and more of that into our computers and the in silico pipeline we have, such that we can accelerate the scientific discovery process in there? So that's really where we're heading.
Hi everyone, welcome to Let's Talk Research, the official InstaDeep podcast where we dive into cutting-edge AI research and the stories behind it. My name is Bora Gulola, I'm a research scientist here at InstaDeep.
And I'm Massimo Bortone, also a research scientist at InstaDeep. Today we're kicking off the new year by reflecting on highlights from 2025 and what's on the horizon for 2026.
Exactly, and joining us today on the episode is our very own head of research, Alex Laterre. Welcome, Alex, and Happy New Year.
Happy New Year to you too, guys. Thanks for having me.
It's great to have you here, Alex. So before we dive into the details, how did you stumble into InstaDeep? How do you get here?
Well, I think my beginning at InstaDeep were quite an adventure. So I joined, I think, almost exactly 8 years ago. And I really remember vividly, actually my first day was in December, but the CEO just called me like 2 weeks before that saying, hey, we have enough site with the company in Tunisia. You have to take book a plane ticket and come join us. So that was actually my first day at InstaDeep, just 2 weeks ahead. And that really set the tone for everything. I think people were super friendly. It was very, very interesting and funny experience to just start that way. And actually, once my first day started, actually, it was also interesting because the CEO actually left me there. We were in a small office of like 4 desks in a WeWork, and we were really passionate by AI. And basically, the CEO told me, "Hey, let's investigate the use of AI for, supply chain, logistics, transportation, all of these things." And then he gave me a challenge, and then he actually left for NeurIPS. He left me there for my first week of onboarding alone, trying to establish, let's say, the first, algorithms to tackle this kind of problem. That's how I started, in the company. So quite a funny experience. I was kind of carefree at the time where I didn't think that much. I mean, I met the CEO and there was just a very good vibe of like, in terms of personality, he really wanted to do what I care about, which was like advanced research and its application. And that's how it started. I just say yes from the get-go. Didn't think at all about any business model, the team, or anything like that. I think they were just passionate by the field, and the CEO. I could feel the CEO. It was really the same thing. So that's how I started, really, and the rest is history.
And of course, since then, you've had a relatively long journey here at InstaDeep, right? And you've spent a lot of that time building up the R&D team and kind of establishing different directions of research. What's that experience been like?
I mean, it's been amazing, right? Like I joined, like I said, in the early days. So I think we had a small office in Tunisia of like 10 people-ish. And then the London office was just the CEO, an intern, and another full-time. And I joined at that time. So as everyone joining an early stage startup, you have to do a lot of multitasking. So I was a bit all around the place. But what really, let's say, represent well my beginning at InstaDeep was really kind of kicking off this kind of research effort for the company, right? So the C and I had a very strong belief that we wanted to show, let's say, the applicability of AI to some, let's say, problems, like I said, in logistics, transportation, really trying to have an impact there. And so our strong belief was, we believe that it's only through, let's say, learning from experience that we can really, it's really the only way to scale and move forward from just using human level data and so on. And so that's how really we started from a technical point of view to say, okay, let's bet on reinforcement learning and let's try to build simulation engine frameworks and really show the applicability of reinforcement learning. And at the same time, from a business point of view, we were also quite aligned with this idea of like, hey, let's kick off research in reinforcement learning, because nowadays as well, I mean, the landscape of AI is dominated by the big tech, but perhaps even more back then, because nowadays you have the capital for plenty of startups to emerge. But back then it was really like Google, DeepMind, OpenAI, and so on. And we picked reinforcement learning because also of a business a business decision, right? Because we then don't need the data that was controlled by the big tech. We could generate our own data from simulation engines. So all in all, combining our deep belief that we have to learn from experience to achieve superhuman, let's say, mastery of some problem, plus the fact that we could be not dependent on data that the big tech would own, makes us believe that we had something there that we really need to push in that direction. And as I mentioned also in the, let's say from a managerial point of view, I came up there with actually no experience whatsoever, right? So everything we did was quite, let's say, authentic. Let's put it that way, because I hadn't observed how, let's say, research was done in other research lab or in academia and so on. So everything what did was very genuine, and we really learn over time, right? There's always a natural entropy of the research we're doing. First, let's say we were behaving a bit like a research lab. Everyone is doing its own project, but then step by step, we professionalize ourselves, and we try to consolidate our effort to our big research verticals and so on. So it's been really a journey of like professionalizing yourself step by step over, I think, like 5-6 years. Now we are at hopefully a stationary regime, even though we're still changing the way we're operating. But it's been an amazing experience, to be fair. And I think I've been learning a lot on my way there. And I think that's the same for everyone that joined the team very early. Like, I think everyone has a lot of agency at InstaDeep. And so we really own our work. And I've been, let's say, very good at hiring good people.
Yeah.
So we could really leverage an amazing team that really built some kind of very strong initiative in the research.
And do you think in the process of all these years that you have been at InstaDeep, that initial spirit that you started with, I think that's still alive? I think.
I think so.
Combination of research and applied.
It's. I think it's all about indeed the culture we set. Sometimes it happens implicitly. Sometimes we have to make some explicit move to keep that there. But I do believe that it's quite intact, especially in the research team has a very good, let's say, like I said, the agency. So we have a lot of freedom to, let's say, investigate what's going to be the future of InstaDeep in a way, because we're inventing the next foundational models or the next algorithm that InstaDeep is going to leverage in their product and for customers as well. So it's quite important. It's a big responsibility that the whole team has, but I think we've been delivering over the years, and hopefully we'll continue like that.
And so obviously we now currently have a much broader research agenda, right? So we've in previous episodes heard about our work in ML for physics, right? Our Gen AI efforts, and as you say, we kind of have a very strong history in RL as well. What's been kind of your experience with taking learnings from these different fields and kind of establishing something broader and translating it from one field to another?
Yeah, I think so. Like you said, so we have very strong research on two important verticals, which is this decision-making AI. So everything related to reinforcement learning, multi-agent system as well, planning, search, quality, diversity, you name it, right? We have done quite a lot there, and we are, I believe, quite successful nowadays. It's really at the forefront of what can be done in that space. And then at the same time, again, back to this idea of like research kind of inventing the future of the company, we started establishing ourselves in the field of like generative AI for biology, right? So we are leading expert in foundation models in genomics. Now we also have very strong generative models on proteomics, antibody design, and so on and so forth. So that's been very successful over the last few years. And now the goal is indeed to kind of bring these things together and this kind of cross-pollination, right? To say we're very good on decision-making, can we apply that to biology? And also the work we've been doing in generative AI in biology, can we apply that to decision-making? Because there's a huge amount of information that exists in, let's say, offline data set, a bit like what we call the pre-training of LLMs for biology. Well, we can do the same for decision-making to say companies have existing data set of the system that have been running, so they've been gathering data over the years. So can we leverage that and build also generative models on the decision-making side and trying then to apply reinforcement learning and so on to squeeze the most of what we can from our algorithm. So in a sense, they've been evolved separately, but now we're trying to bring them together and see what are the positive, let's say, interaction we can find in the middle.
Is that also how customers approach you nowadays? Like they see the sort of the work that we do in like more research side of things, like genomics and proteomics, and then they come and ask you, can you maybe use these techniques in our industrial field, or does that happen?
Yeah, that's a learning we had over the years. So InstaDeep has always been very open to, let's say, the research we do. We've been publishing, open sourcing models and the like, right? And we did that for, let's say, two reasons. The first is hiring. We want to attract people that want to do the same thing as we do. So it's important to show our work such that they can see we're doing that and they come to us. But then the second one, more importantly, is around the business. To say, indeed, if we show our work, actually some of the biggest partnership we signed over the years were due to the research that we did and that they saw, and then they came to us. So this kind of conversation starter came from the research we had put out there, where it's about, for example, Deutsche Bahn, with who we work on multi-agent system for, let's say, the orchestration of train on their railway infrastructure, or is it BioNTech, which is our parents' company now. It also came from the fact that we had shown our research and then they come to us, and that's how we started conversation. So it's been hugely important for us for multiple reasons. Obviously, researchers, they want to also open the research to have an impact and contribute back to the scientific community, but also from a business point of view, it makes sense for us. And that's why actually we close a lot of our biggest partnership.
Mm. And kind of looking at the research output that we've had, right, especially the past year has been quite significant in that we've published a lot of new stuff. We've worked on a lot of interesting projects, really exciting stuff. Do you want to give us a little kind of rundown of what you found to be the most exciting?
Yeah, it's true that we don't necessarily realize that. Actually, it's been almost exactly 1 year ago where we had the chance to publish for the first time our work in nature method with our nucleotide transformer models. So it came out in November or December of last year. So that's actually a big milestone for us, because we have set ourselves the objective of like growing a bit the ambition of the research we wanted to do and target a top tier journal. So that was a big milestone for us of like publishing in Nature Method and showing a work that we've been doing in foundational models in genomics. But actually since then, we actually reiterated that experience actually 6 times over the years. So we published 6 nature journals in the last year. The first one being nucleotide transformers, but then our work on generative AI for proteomics, antibody design. We even made the cover of Nature Machine Intelligence with our work combining genomics foundation models and English language models that use, let's say, English as binding interface for a lot of downstream applications. So that's been a super successful year. And like I said, it was very intentional. We really wanted to grow the ambition we had in the research team and really go to the next level in terms of publication and potential impact. And on the other side, we keep publishing at machine learning conference because there, the target audience is a bit different. We want really to target ML practitioner and researcher, not less computational biologists and the like, right? So we keep publishing at a machine learning conference. Actually, the team just came back from San Diego, from the NeurIPS conference, where we actually, again, for the first time in the history of the company, we published 3 main track papers, including a Norwal and a Spotlight. So it's been amazing year on so many fronts. So I'm very happy of let's say the success. This is very tangible these days, but it's also the result of a lot like build up over the years.
Yeah, and I hope we can keep the momentum for the year ahead.
Yeah, I mean, to be fair, we'll continue to professionalize ourselves or software stack or research and really try to aim higher and higher in terms of level ambition. Really, it's simply a natural continuation right now. Like I mentioned, we have important verticals on decision making and generative AI for biology, so we'll carry on this as independent tracks. So really, on the reinforcement side, we're gonna try to capture the entire value chain in a sense. So what we're trying to think of in terms of building a reinforcement application, you have the offline learning, you have the online learning with classic reinforcement algorithms, and then you have the deployment. And so we're trying to be the best at these 3 stages to say, let's build the best offline ML algorithm, the best online algorithms with multi-objective, multi-agent system. And then at deployment, we want test time compute instead of just doing random sampling. of your policy, you try to have a more systematic way of approaching problems and really try to squeeze the most of the performance of your model. So really trying to master the entire chain there. So that's what we're going for. On the digital biology side, well, we keep developing more and more sophisticated foundation models in biology that are multimodal, that allow a strong steerability in terms of what can be generated and so on. So we're going to keep pushing that, especially on the genomics and proteomics side. And then, as I mentioned, a natural continuation is to actually develop project at the intersection of these two. So pushing towards idea like the lab in the loop to say, hey, we can generate candidates, we can optimize, let's say, the design of a sequence and so on. And now, thanks to our approach on machine learning for quantum chemistry, we also have good property predictors. So can we push more and more of the work of designing a new antibody to be completely in silico, as opposed to having to do a lot of wet lab experiments, a lot of rounds? Can we push more and more of that into our computers and the in silico pipeline we have, such that we can accelerate the scientific discovery process in there? So that's really where we're heading. It's a long road there, but we got very successful, let's say, in vitro experiment last year on the genomic side and the antibody side. So I'm quite confident there's a sign of life there that we can really push way forward for 2026.
And what do you kind of see as the, for lack of a better word, right, like challenges or things that need to be things that need to fall into place for this work to scale, to kind of merge and to essentially keep being pushed in the right direction?
Yeah, I mean, good question. I mean, let's say they're obviously like technical risk to what we're trying to achieve, right? So we mentioned capacity to steer multimodal foundation models, which is really not straightforward. There's a lot of research in that space nowadays that we are carry on internally, but also a lot externally happening. There's a lot on the capacity to evaluate the properties that we care about, right? When we have a very large search space, it's important to have accurate predictors of the property you want, because only actually a few of them have the right property to move forward in the pipeline, right? So there's plenty of technical problems there that we have to solve in terms of active learning and so on. So that's one. Then obviously, from a strategic and managerial and structural point of view, also with 50 people in the research team and coordinating everyone toward this North Star is not necessarily easy, because we're all super eager to do what we believe is the right next research project. So we're trying to find a good balance there between top-down, bottom-up approach. I think it's important to have a natural entropy and leaving a lot of freedom for people to explore. So finding this balance is a tricky one, especially when we have more and more ambition. So we need more and more people to working towards a similar objective. So I would say, yeah, these are the two separate. And then, of course, there's, let's say, having the means to achieve what we want to do in terms of AI, right? It's like today's AI is very much an engineering science, more and more. A few years ago, we had a deep learning paradigm shift. Now we have this area of scaling. So it's important to have the compute resources that we need, and we build infrastructure to do that. But we also need data and wet lab validation to really show to the world that our in silico algorithms are actually working in the real world. So that's also another aspect that we have, let's say, to professionalize in the coming year.
Mm-hmm. I have maybe a bit more personal question. So you have your fingers in all of these different pies, let's say, of research. How do you keep yourself up to date to the point where you can actually engage with all these different research directions, which are very multidisciplinary? Like you go from biology to physics, chemistry, and sometimes like hardcore machine learning engineering.
Yeah, I mean, that's also what makes the job interesting, right?
Yeah, I bet.
Well, fortunately, we grew that over the years, right? So it didn't fall on my lap, from day one. So I've done a lot on the reinforcement side at first, and then opening yourself up to generative AI in biology and genomics and proteomics. So really learning from everybody, to be fair, in the room. And there's also ML system, which are becoming more and more important as well. So let's say it's just like learning on the job, like I've done on the managerial side, trying to do on the technical side. So that's one. I think it's important for me, like on a personal level, I try not to put myself on the critical path of project because otherwise I would slow them down, but really trying to stay in the neighborhood of this project by having side project and trying to work a bit with the team on the sub project within the big one. So really trying to stay close to the team and working with the team lead and so on. And then from time to time when I find the time to really code and do some side project in that space and hopefully sometimes contributing to the main effort. But I'm realistic that I don't necessarily have the time to do that every day.
Yeah, but I mean, it's still super important to have at least some exposure to, let's say, what's happening on the ground, right? You have very good understanding of kind of the code bases that we work with, right? And you actually work in them yourself as well. So that also then allows me, for example, to come up to you and say like, oh, Alex, we're having this problem, right? Like, what do we think is the solution here, right? So it's really nice to kind of have that input from you as well.
Yeah, I mean, it's part of that's part of the job that is the most enjoyable, right? Really working with the team. I mean, if I try to find the highlight of my time, it's always been working on concrete problems with the team and really be able to kind of code and just contribute to projects. So that's clearly something that is extremely enjoyable and trying to stay there. But I agree with Massimo as well, right? There's a huge amount to cover. So obviously I can't be proficient everywhere, but really trying my best to support the team there.
And kind of, if I can ask a little bit more about your experience with ML systems, right? So obviously there is all this research work that goes on, right? Yeah. A lot of theory, a lot of application, and so on and so forth. But there's also kind of the infrastructure, the code quality, the kind of everything that goes into actually making these kind of big ambitious projects happen, right? What's been your...
So yeah, as mentioned, AI is very much engineering science. And actually at InstaDeep, I think we're one of the few in the world that really acknowledge that from the get-go. I think there's this famous story of Jensen, the CEO of NVIDIA, delivering the first AI supercomputer, DGX-1, to OpenAI. Back in the day, they were unknown to the public, right? But Jensen delivered that to Elon Musk and Sam Altman and so on. But actually, a few months later, InstaDeep, this small company of like 20 people, partially in Tunisia and in London, we received also our first DGX, not from Jensen, unfortunately, but we made this huge investment back in the day of acquiring our own hardware, really because we believe that first compute would be paramount for all the works that AI would be doing. We didn't obviously predict the scaling laws, but we strongly believe that compute was very important already in 2016, 17. And so we kept going in that direction, and we kept acquiring the next generation of the best AI hardware out there. So NVIDIA V100, A100, 40, 80 gig, and nowadays H100 and the like. So that's been a journey of like keep acquiring our hardware. And actually last year we released Kyber, which is our latest generation of the AI supercomputer made of NVIDIA H100. So we always hosted our own hardware because we have a strong belief that you need an intense kind of co-development between the hardware that you have and the algorithm you're going to design to really squeeze the most performance. And also in terms of investment, we want to optimize the performance per dollar that you get, as opposed to perhaps using cloud provider and so on. In the end, you have a huge return on investment if you own your hardware. That brings a lot of risk because you don't necessarily know what's going to be the workload you're going to have, but it's a very strong belief that only through in tight hardware, software, let's say integration, you're going to get the best performance to achieve the objective you want. So that's really been the mentality we had from the get-go, and we build actually quite a sophisticated software stack on top of our hardware and build product around and so on. And I believe that's thanks to that our team is as efficient as it is today of like submitting jobs. Like actually, I believe we're submitting around 15,000 jobs to our cluster every month for like 250 engineers, something like that. So that's quite a lot. And we maintain also our GPUs very high. So engineers are very easy to please. The more compute you give them, the better, and they're happy. So in a way, it would be infinite the amount of compute we need. But I believe we're well set with Kyber, even though I'm looking at the next generation also of the cluster we'll build together.
Yeah, I mean it's always really nice not having to think about kind of, okay, I have these 10 experiments that I want to run, right? And not have to prioritize them and just be able to submit and go for it.
Yeah,
right?
you can't take that for granted.
Yeah.
Coming from university, but also in other companies, I think, yeah, you can't take it for granted.
Yeah, absolutely. And what we also can't always take for granted is the emphasis that the company places on research, right? As we've kind of discussed, there's this huge, very broad, very wide-ranging research agenda. And that's kind of a choice that the company has made, right, to actually publish this. And it's not necessarily a given. I just wanted to kind of see if you have any thoughts on that.
Yeah, absolutely, I agree. Like, I need to give the full credit here to the CEO, which really has this optimism and drive towards AI, and the research can be done there. So he really set the tone. At the end of the day, InstaDeep is a research-led organization. So we put a lot of emphasis on the research. And it's also not just by pure, let's say, like I said, optimism, but it's also a strategic decision. Like the research team has opened a lot of doors for the company. We developed the first foundation models in genomics, and now we actually have customers in that space and even product. We have done a lot of work on, let's say, reinforcement learning for combinatorial optimization, which we now use these algorithms in actually our product on chip design. So all of that really came to fruition. So it's really kind of an investment on InstaDeep side, but it's been strategically a successful one, if you want. And that's also due to the mentality we have in the research, where we consider research being successful if it hits two milestones, which is the first one, let's say, contributing back to the scientific community. We open source a lot of our models, like I mentioned, but also having the potential for impact. It doesn't have it within InstaDeep, right? It doesn't mean that every paper, every project must have an impact. Maybe you need a few iterations of a research to actually be meaningful and impactful. But at some point, we InstaDeep and we want to have an impact on the business of the company. So that's quite important. And as I mentioned, back to this kind of open science and open research initiative, we open source a lot of the models, and our research also, because of the business, benefit from it towards hiring and also getting partnership and starting conversation there. So that's why I believe InstaDeep has made this bet, which is quite special for a startup, because when you're in a startup, you want to stay lean, you want to avoid wasting money or wasting resources towards stuff that can't be immediately applicable or solve the problems and get you more customer to the door. So it's really, like I said, credit to the CEO for having taken that risk and for having set the tone and that culture very early on. And I think that's one of the key aspects that made InstaDeep successful.
Yeah, and it's a risk that they keep on taking because, research is a very long payoff often.
Yeah.
All right, Alex. Yeah, it was great having you here and chatting with us. And to our listeners, thank you for tuning in into another episode of Let's Talk Research. We hope to see you next month, where we will be talking about how our own infrastructure is powering research at InstaDeep.
You won't want to miss it, and we'll see you then.
Bye-bye.